The way we view the universe has a profound impact on our understanding of ourselves. Today we see the Earth as a small, fragile globe, orbiting at just the right distance from the Sun for life to flourish. It appears to be the only planet with life in the solar system, and the planets themselves are mere specks in the vacuum of space. Human life seems reduced to insignificance when set against the vast, nearly empty spaces of modern astronomy. But before the modern era, the universe appeared much more comfortable and accommodating. Thus, medieval European cosmology placed the Earth in the center of a small spherical universe surrounded by the abode of God and the elect. In this study, we will explore an early Earth-centered conception of the cosmos from India. This cosmological system is presented in the Bhagavad Purana, or Srimad Bhagavatam, one of India's important sacred texts. We begin with a brief outline of this system. First of all, the Bhagavatam describes innumerable universes. Each one is contained in a spherical shell surrounded by layers of elemental matter that mark the boundary between mundane space and the unlimited spiritual world. The region within the shell is called the Brahmanda, or Brahma egg. It contains an earth disk called Bhumandala that divides it into an upper heavenly half and a subterranean half filled with amniotic water. Although Bhumandala literally means the circle or mandala of the earth, it has little in common with the earth on which we stand. The diameter of Bhumandala is given in the Bhagavatam, and it is about the size of the orbit of Uranus. Bhumandala is divided into a series of geographic features called oceans and islands. But these are geometrically perfect rings of cosmic size with no resemblance to irregular earthly continents. In the center of Bhumandala is the circular island of Jambudvip, with 9 subdivisions called Varshas. These include Bharatavarsha, which can be understood in one sense as India, and in another as the total area inhabited by ordinary human beings. Jambudvip is centered on the geometrically shaped Sumeru mountain, which represents the world axis and is surmounted by the city of Brahma, the universal creator. The Bhagavatam presents astronomy in geographical and mythological language, and the mode of presentation is different from the familiar modern approach. Although the earth disk of Bhumandala may look naively unrealistic, careful study shows that the Bhagavatam uses it to represent at least 4 different reasonable and consistent models. These are: 1. A polar projection map of the Earth globe. 2. A map of the solar system. 3. Topographical map of South-Central Asia. 4. A map of the celestial realm of the demigods. There are bound to be contradictions when one structure is used to represent several different things in a composite map. But these do not cause a problem if we understand the underlying intent. We can draw a parallel with medieval paintings portraying several different parts of a story in one composition. This painting shows St. Peter in 3 different parts of a biblical story. Here is a similar painting from India showing 3 different parts of a story about Krishna. Such paintings contain apparent contradictions, such as the images of one character in different places. But a person who understands the storyline will not be disturbed by this. As source material, we will refer to the Bhagavad Purana and to several important commentaries on this text by traditional Indian scholars. We will also refer to the great Indian epic, the Mahabharata, to other sacred texts, including the Vishnu Purana, and to important Indian astronomical works, such as the Surya Siddhanta. Bhumandala as a planisphere. We begin by discussing the interpretation of Bhumandala as a planisphere, a polar projection map of the Earth globe. Each important interpretation of Bhumandala is obtained by focusing on a cluster of Bhumandala features and temporarily ignoring features outside the cluster. In this case, note that the ring-shaped islands and oceans of Bhumandala have widely varying scales as defined in the Bhagavatam. For now, we ignore this. The planisphere interpretation of Bhumandala requires that we give them all equal width. In fact, this is commonly done in diagrams of Bhumandala, such as this one, dating to the early 19th century. Bhumandala with equalized rings can be seen as a stereographic projection of a spherical Earth. Stereographic projection is an ancient method of mapping points on the surface of a sphere to points on a plane. This method can be applied to map a modern Earth globe onto a plane. This flat projection is called a planisphere. Bhumandala can likewise be viewed as a stereographic projection of a globe. Such globes exist in India. Here is one that was probably commissioned by Sawai Jai Singh, Raja of Jaipur, in the early 18th century. In this globe, the land area between the equator and the mountain arc is Bharatavarsha, corresponding to Greater India. India is well represented, but apart from a few references to neighboring places, this globe does not give a realistic map of the Earth. It was clearly intended for astronomical rather than geographical purposes. Here is another globe showing Jambudweep. Note that Jambudweep is mapped into the northern hemisphere on these globes. Although the Bhagavatam does not explicitly describe the Earth as a globe, it does so indirectly. For example, it points out that night prevails diametrically opposite to a point where it is day. Likewise, there is sunset opposite a point where the sun is rising. According to the Bhagavatam, the sun orbits just above Bhumandala on its chariot. Taken literally, the sun's rays should spread out smoothly over the plane of Bhumandala, leaving no points of sunrise or sunset, and no area in total darkness. This seems to contradict the Bhagavatam's statement about day and night at diametrically opposite points. But there is no contradiction if we adopt the planisphere interpretation of Bhumandala. To see this, consider the equator, the Tropic of Cancer, the Tropic of Capricorn, and the sun's path called the ecliptic. These circles are mapped on a globe as we see here. The sun is always directly above some point on the ecliptic, and the globe rotates relative to the sun plus ecliptic once per day. The sun also slowly moves along the ecliptic, making one circuit per year. The seasons result from the sun's northward and southward movement on the tilted ecliptic circle. These four circles project stereographically as shown here. The ecliptic projects onto an off-centered circle in the planisphere map, and the sun's position on this map corresponds to the point on the Earth globe where the sun is at the zenith. The terminator, or boundary between day and night, is a great circle on the globe that is perpendicular to the sun's zenith position. It projects stereographically onto a circular arc on the planisphere that rotates once every 24 hours. At the equinoxes, this arc becomes a straight line. At the solstices, it bends so that the north polar region is illuminated in the northern summer, or in darkness in northern winter.